Hey Algebra 2, today we're going to be talking about combinations. Now combinations are kind of like permutations, except it is a selection of objects. That looks really ugly. A selection of objects, just like the permutation, without regard to order. Okay. Permutations, we cared about the order, like how many permutations if the last letter of the word ends with a E or something like that. So combinations actually without regard to order. So we don't care in which order what goes. So for an example, if I were to give you A, B, C, D, E, and F, and I were to ask you how many combinations of 4 of these letters can be selected from these 6, okay? Well, if you think about it, there's 6 possibilities, right? There's 6 possibilities, but we're going to divide that, let me start over. We have our 4 spots. We know that there's 6 options for the first one, 5 for the next, 4 for the next, and then 3 for those 4 sections. But even amongst those 4 of these 4 spots, there's 4 different combinations of these, okay? So we're going to have to take this 6, 5, 4, 3, and we're going to divide that, okay, by 4, 3, 2, 1, okay? Because these 6 combinations, the number of these combinations, these 6 things can be taken 4 at a time. Okay? So, if we were to work that out, we'd end up with 15, because these cancel out, that reduces, and we get 15. Well, the question is, can we come up with a little formula or identity with this? Well, there's 6 numbers. So we did 6, 5, 4, 3. And on the bottom we did 4, 3, 2, 1. Well, if we can go ahead and add on 2, 1, we can write this as a factorial. And remember, you can multiply anything on top as long as you multiply the same thing on bottom. Okay? 6, 5, 4, 3, 2, 1. So now we can rewrite this as 6 factorial over, here we have 4 factorial times 2 factorial. Okay, so what we're going to end up doing here is coming up with our little identity here. Well, however many numbers are up top, n factorial, okay, we're going to call this first number, we're going to call that r. So notice we did 6 and 4, that's what we were talking about. So we're going to call that r factorial. And 2 compared to 4 is 6 minus 4 is 2. 6 minus 4 is 2, so we have n minus r factorial. Okay? So this is what we're going to be using to solve the rest of these. Maybe that was quite confusing as we did this, but it'll probably make more sense as we work through this next problem. How many different 4-member committees can be formed from 9 people? Now there's certain notation you're going to find on the homework, and it looks like this, 9 and 4. So how many 4-member committees, that's where we get the 4, can be formed from 9 people? That's how we get the number on top. Well, this is in the format of n and then r. Well, if we know how to apply these, this ends up being not much work at all. So n goes up top, so 9 factorial over, it says r factorial, which is 4 factorial, times, it says n minus 4, so 9 minus 4, so times 5 factorial. Okay? Again, number up top, goes up top, n. The bottom number 4 starts here, that's our r, and do 9 minus 4, so 5 factorial. So to work this out, we do 9 times 8 times 7 times 6 times 5 factorial. 4, 3, 2, 1, 5 factorial. When we do this, the 5 factorial cancels out. 4 goes into 8 twice. 3 goes into 9 3 times. 2 goes into 6 3 times. So we have 6 times 21, which is, sorry, 126. So there are 126 different 4-member committees that can be formed from 9 people. Okay? Alright. Let's go to our next problem. 8 points. A through H are on a circle. So if you imagine a circle, you have all these points on the circle. A, B, C, D, E, and so on and so forth. A through H. Okay? Actually, might as well just finish it. G, H. It says how many lines are determined by 8 points. So our notation, we have 8 on top. Well, how many points create a line? Well, all you need is 2 points to create a line. So the 2 is going to go here. Okay? So again, this is our N, this is our R. So now we do 8 factorial. Actually, I'll write it up there. So now we have 8 factorial. This is our R, so 2 factorial. 8 minus 2 is 6 factorial. Okay? So when I break this down, I have 8 times 7 times 6 factorial. 2 times 1 times 6 factorial. So these cancel out. 2 goes into 8 4 times. 4 times 7 is 28. There you go. So this is for letter A. How many lines? So there's 28 lines that you can create here. Okay? So it's like 1, 2, 3, and then so on and so forth. 28 of them. Okay? And B says how many triangles are determined by 8 points. Well, if you think about triangles, how many points creates a triangle? That'd be 3. So if you, oh, look at that. So if you're trying to draw the triangle, again, you need 3 points to create a triangle. So that's going to be 8 factorial over 3 factorial. 8 minus 3 is 5. So if we were to write this out, this would be 8 times 7 times 6 times 5 factorial. 3 times 2 times 1 times 5 factorial. Therefore, these cross out. 3 goes into 6 twice. 2 goes into 8 4 times. So we have 8 times 7 is 56. Okay, so there's 56 triangles that you can create amongst these 8 points. So good luck with that. I hope it's making some sense. And yeah, so again, this notation here, top number is your N, bottom number is your R, and the number that goes here is you subtract 4 times 9 minus 4. And that's how we got the 5. Okay? And then you'll just cross them out from there. And remember, you always want to go to your biggest factorial and bottom. So 9, 8, 7, 6, 5. Could you technically go to 4? Sure, but you're going to end up with the same answer anyways, but with just a little bit extra work. So might as well cross out the biggest one first. So these are combinations. Good luck.